Hi everyone, welcome to today's presentation. We're going to introduce a Flink Pulsar SQL Connector. Before we get started, I want to do a quick introduction about myself. My name is Zhang Yufei. I'm a cat person. On the right side, you can see a picture of my lovely cat. Her name is Bounce. I work at StreamNative, working with Pulsar and Flink. We aim to build a better integration experience between Pulsar and Flink. I contribute to multiple Apache projects, including Pulsar and Flink, of course, and I also contribute to RocketMQ. We will first walk through the basics of the Flink Pulsar SQL Connector, including concepts and use cases. Then we will introduce another important component, the PulsarCatalog, which helps us better manage the relationship between Flink tables and Pulsar topics. After that, I'm going to do a quick demo to illustrate everything we will be talking about today. And finally, I'm going to share some tips and resources that might help you better use the Flink Pulsar SQL Connector. Let's get started. Well, first, what is the Flink Pulsar SQL Connector? If you are not very familiar with the Flink API, we need to know that Flink has two APIs, DataStream and the SQL Table API. In DataStream API, engineers need to write Java, Python, or Scala code to describe their Flink jobs. And in SQL Table API, you can use SQL scripts to describe the Flink jobs. Of course, the Flink Pulsar SQL Connector is just a connector for the SQL API, and for simplicity, I will just use the SQL connector to refer to the Flink Pulsar SQL Connector. In fact, the Flink Pulsar SQL Connector allows using Pulsar topics as the Flink tables, and thus we can read from and write into Pulsar topics. Well, you might be wondering, what can the SQL connector do? The first place we can use it is to use it in conjunction with the DataStream API to simplify our job definition. We can use the SQL connector as a pre-processing step and then connect it with the DataStream job. In fact, the SQL connector is built on top of the Pulsar Flink DataStream connector, which is already available as the official Flink repository. It inherits all the config options from the DataStream connector and has the same processing guarantee and performance as the DataStream connector. If we look at this very simple benchmark of which aims to detect if there is any performance differences between the DataStream and the SQL connector, we can actually find that they nearly perform the same. The only difference is the JSON. This is because when the SQL connector introduced another layer of deserialization and serialization. However, this difference is totally acceptable. Secondly, you can write SQL instead of Java or Python with the help of a SQL connector. This is very helpful because it allows non-engineer teams to write Flink jobs, such as BI teams and marketing teams. They can write SQL scripts to investigate data stored in the Pulsar topics. And in fact, it brings us a faster job submission because it does not require any code to packaging. Let's use a Java project as an example. So in a Java setup, you probably want to have a Maven project, and then you need to write up your code, and probably there is another CI/CD pipelines. And after all this, everything will be packed into a jar. And finally, you even need to put the jar inside the Docker file before you can submit to a Flink. However, with the help of SQL client provided by the Flink itself, we can just launch a SQL client and write SQL scripts, press enter, and the job will be submitted. And this brings us to another good result, which is you can run fast ad-hoc queries and see immediate results. You can run easily in window aggregations and other types of computations, and you can see the results immediately and interactively, just like shown in the picture. Well, so how to use it? Well, there is the standard way, or the way I prefer to use it is to use a SQL client. You just need to make sure the jar is put on the class path of when you are launching the SQL client. You can also use the table API, which you still need to write a Java or Scala code, but we won't come to that detail in this presentation. Okay, let's look at a simple example. First, this is create table statements. We're creating a table called SQL user using the SQL connector. And we can see the column definitions. like age, name, income, and single. And then we will see the watermark definitions. It basically specifies how to define the watermarks based on what column, and the Flink will then use this watermark information to generate the watermarks. And finally, it's a connector configs. As you can see here, the connector is set to Pulsar, and the admin URL service URL points to a Pulsar cluster. The topics means which topics this Flink table will be mapped to. And finally, there is a format, and we will come to this detail later. Now we're going to introduce a cool feature called the metadata columns. Here is some background information that each Pulsar message is associated with metadata, such as which topic it comes from, what is the publish time of it, what is the event time of it, how large is this message. And with the metadata columns, our Flink Pulsar SQL Connector allows users to declare columns that should be mapped from a Pulsar message metadata. For example, here, if you look at the event time column, it's actually coming from a metadata with the key event underscore time. Similarly, there is a metadata, a column called a message size. However, there is a virtue there. What does the virtue here means? Well, virtue means that this metadata is only available at the source, where you can have this metadata when you are reading from a Pulsar topics, but it will be ignored when you are writing into a Pulsar topic. And this is natural because for message size, it's metadata decided by the Pulsar clients, and you cannot set arbitrary message size for any messages. It will be decided automatically. So when you are writing to a Pulsar topics, you cannot really set any value for it. Here is a table of all the metadata you can use. As you can see here, most of them are read-only, and the last one is a little bit special, and it's event time. It's writable. And this means you can actually set the event time metadata when you want to send data from Flink to Pulsar. Okay, this is about the metadata columns. Next, we're going to introduce the Pulsar schema and the Flink formats. Still, I want to provide some background information as well. We know that Pulsar has a schema system. What does this schema system do? The Pulsar schema basically defines the structure of the data stored in Pulsar topics. Similarly, Flink has a table schema as well. It defines the structure of the data to be processed in Flink. Now here comes the question. How does the Pulsar SQL Connector translate or map the structure in Pulsar to structure in Flink? That's where the Flink format kicks in. You can think of Flink format as this. It helps Flink jobs to map the binary data stored in the Pulsar topic to Flink table columns. We know that Pulsar has JSON schema, average schema, primitive, and protobuf. And we know that Flink format has some provided and existing formats, such as JSON, Avro, CSV, and raw, etc. So for example, if you are using JSON in the Pulsar topics, and then you can specify the Flink formats to be JSON, and then you can read from the Pulsar topic. However, there are some restrictions. As you can see here, protobuf schema is actually not supported because Flink does not have a protobuf format yet. Well, we must be careful that since Flink only treats all data as binary data, no matter what the Pulsar schema the topic uses, from the Flink's point of view, they're all binary data. And this means that the Flink formats can go beyond the limitation of the Pulsar schema. Let's look at this example. So let's say we have a Flink job A, it reads from some data source, and it's writing using CSV format. Notice that the Pulsar does not have a CSV schema here. So from the Pulsar's point of view, all it received is just some binary data. And we have another Flink job B here, it's reading using CSV as well. And when Pulsar sends out the data to Flink job B, it still consider it as a binary data only. The Flink job B can deserialize the data, deserialize the binary data, of course, and send out to another system. So this way you can actually have a very flexible Flink format choice, as long as you know what kind of binary data you are storing in the Pulsar topic, and you have a matching Flink formats. Well, let's do a quick summary of what we have already covered. The Flink Pulsar SQL Connector is highly configurable, And this is because the Flink Pulsar SQL Connector is built on top of the DataStream connector, and it supports all the config options provided by the DataStream connector. And secondly, it's very easy to use. It helps you to easily navigate, investigate the data stored in Pulsar topics with just a few SQL lines. You don't need to do any packaging, and you can see the results interactively and immediately. And lastly, we actually support various kinds of data schemas. As long as binary format stored in the Pulsar topic is understandable by the Flink formats, it can be loaded to or written from the Flink SQL jobs. Well, next, we're going to talk about the Pulsar catalog. What is a Pulsar catalog? Well, a catalog is where Flink SQL stores table metadata. And by default, Flink stores the metadata in memory, which means if you restart the whole SQL client, the table definition will be lost because it's not persisted. And fortunately, Flink allows us to use external systems as catalog. In our case, that's where the Pulsar catalog comes from. We store the Flink table metadata in Pulsar topics. If we want to create a catalog Pulsar, it's very simple. You can just use the SQL scripts below. As you can see here, the type is Pulsar catalog, and it points to a Pulsar cluster by specifying the admin URL and service URL. Create a table in Pulsar catalog is easy. You first need to use the catalog, and then you need to create a database. Here, we create a database called the SQL examples, and then we use the database SQL examples. After that, we can just execute the create a table statement to create a table named SQL user. It's very normal. It's just like any other SQL connectors. And here, the table like SQL user are called explicit table. And we'll come to the details later why they are called explicit tables. Here is how the table metadata is stored in Pulsar. It's very easy. So this is using an example. Still, let's say we have a Flink table. Its name is SQL_user, and the topic it should map to is sample/Flink/user. Here, sample refers to which tenant it resides in. Flink is a namespace, and user is a topic name. These are all Pulsar concepts. So normally, we would imagine there is a topic name user under the sample/Flink namespace, right? That's right, because all the data flows from the topic user to the Flink table. However, the table metadata is stored in another topic. This topic resides in a system tenant called Flink Catalog. And you might have noticed that the namespace name SQL examples is the same as the database name we have created earlier, right? So here, this is how we create a table mapping between a Pulsar topic, a Pulsar metadata topic, and a Flink table. Such kind of table is called a placeholder topic because it does not contain any actual data. We just use the metadata of this placeholder topic to store the metadata for the Flink table. That sounds curious, right? So if we look at the content of the metadata of that topic, we'll get something like this. The name is table_SQL_user, and you can see all the Flink schemas are available in the JSON. Well, that's pretty much for the explicit table, but we can go a step further. Can we skip the create a statement? Well, this is actually doable. And why we can do that? This is because the Pulsar schema already has the structure of the data. And based on this observation, we can actually automatically define the Flink table schemas based on the Pulsar schema, if it has one, of course. And this is what we did. As you can see here, we would imagine this workflow to be like, okay, you create a catalog of Pulsar first, and then you use a catalog. And you probably want to use a tenant and namespace as a database name. And then you will use a topic name as a table name here. This kind of table is called the native table. It supports direct queries from Pulsar topics. And in fact, these tables are created automatically, and it's mapped from existing Pulsar topics in the connected cluster. The column names of the native tables are inferred. It will be the same as the JSON key name or the Avro field name, depending on which kind of schema you're using. Or if it's just non-structured data, then the column will have only one column and its name will be value. For this kind of table, you do not need any create statement. And this is why, this also explains why the earlier type of table are called explicit, because that kind of table requires an explicit create table statement. It's very easy to use for simple queries for users to navigate through the Pulsar data to do some simple data digging to see if anything goes wrong here. But it also comes with a lot of restrictions, such as since it's created automatically, you cannot specify any watermarks. You can specify a metadata or primary key. And since you cannot specify watermark strategies, you can do window aggregations and similar operations as well. But don't worry, native table and an explicit table won't conflict with each other. You can create an explicit table on the same topic and they will work just as fine. Okay, we have covered the important aspects of the Flink Pulsar SQL connector. Well, now next going to do a quick demo, and here it goes. We're now inside this Flink example repository. Our first thing needs to do is to create a running Pulsar instance and log into a Flink container. This can be done by running this docker compose run Flink command. It will give us a running Pulsar cluster, and we will now log into this Flink container. Then we start our Flink cluster, start cluster.sh. And then we will start a SQL client. Because all the dependencies of Pulsar SQL connector is installed already, we can just start the SQL client directly. Okay, now we're inside this Flink SQL client. Let's take a look around. We'll first show current catalog. And as you can see, we're using default catalog, which is a generic in-memory catalog. But since we're demonstrating Pulsar catalog, we're not using this one. So I'm going to copy this code here to create a new Pulsar catalog. Its name will be Pulsar. And then we'll use catalog Pulsar. Cool. Let's show current catalog again. We're now in Pulsar. Then let's take a look around what's the databases here. Show databases. As you can see here, there are 4 existing databases. The first one is created when the Pulsar catalog is created. The last 3 will scan from the existing Pulsar tenants and namespaces. So if we go to a Pulsar and use Pulsar command line tool, this is called Pulsar CTL, and we can do a namespaces list. What's the tenant name sample? Yeah, and you can see here, this is namespaces called NS1 under tenant sample. That's what that is exactly the database name here. So now for our demonstration, we need to create a new namespaces. Let's create a namespace create. I think it's this command. Okay, Pulsar CTL namespaces create sample/link. Okay, we'll create a new namespace here, and then we'll do the show database again. As you can see here, there is a new database coming out because it's created automatically. And then we're going to create a topic. Topic is we'll create a topic called sample Flink user with a 4 partition, and now it's there already. So let's first start by explicit table. Now, next thing we're gonna do, let's create a new database to use, all right? Then we can do create database SQL examples, and then use database. No database. Just use SQL examples. Okay, we're inside this database. Let's see what are the tables here. Okay, there is no tables yet because we just created the database. And now we're going to create a new table here. We're using the same example in the slide, which, as you can see here, it's SQL user. And one thing I want to mention, there is some tiny differences. As you can see within the connector configs, there is no like connection related config such as admin URL or service URL. This is because while you are using a Pulsar catalog, you cannot you can ignore the connection URLs, and it will use the default URL coming from the Pulsar catalog, which is here. So here we can just save a couple of lines and execute the create statement. The create statement, like there are 4 columns, and this is a watermark strategies. And next, we're going to do a window aggregation query from it. As you can see here, this window aggregation query, it will group by a 10-second tumbling window and whether this user is single or not. And it will show us the single status and the window start time, and then calculate the sum of ages of all the users. Now let's submit this query. Since this table is kind of mapped to this topic here, sample Flink user, and there is no data flowing in that topic now, we're going to produce some users into that topic. This can be done by produce user.sh. It's just going to put some random users inside. Okay, as you can see here, we can wait for a couple of seconds since the data, everything is ramping up, and there's a 10 seconds window. You will only see the data once the 10 seconds window is done. Okay, we have our first set of data coming in, the second set of data, and you can see there's a 10 seconds interval. Okay, and we're seeing more and more data coming out of the pipeline, which is very good. Okay, now we have seen this a lot. We can quit this simple query. And in fact, you can not only query from this topic, you can also insert into this table as well. For example, if we just insert one record only here, insert into SQL users using such value. Okay, let's submit this, wait for the job to complete. And then we're going to kind of like select this, select from the table where name equals to Alice, which we just inserted into. Cool. Let's wait for a couple of seconds and wait for the job to spawn up. Okay, now we're seeing a record popping out from the window, and it means that the query has been successful. Cool. Let's quit, and that's pretty much the basic use of an explicit table. And once we're done with it, we can kind of stop this producer program here, and then show tables. As you can see, we have a SQL user here, and we can drop it. SQL user. Oh, sorry, I need to drop table SQL user. Yeah, and it's done already. Cool. This is about the explicit table, but as we mentioned earlier, we can also query from a native table as well, right? So let's go to a native table and show the databases. Because table, the topic we are reading from is in sample Flink, we are going to use this database. So we use sample/Flink. Notice I'm using a special mark to around the database name, and we can show tables here. Okay, as you can see here, this is a table name called user. It's mapped directly from the topic named the user, and we can actually select from this user as well. For example, we can select, one second, select start from user. I'm gonna limit 10, only query 10 records at a time. Okay, well, seeing the data is coming out of it, and similarly, we can insert into this table as well. For example, if we do insert into user values, and let's wait for it to finish. The username is called Bob, and then we select from user named Bob here. Okay, cool. Let's wait for a couple of seconds and it should be coming up right about time. Okay, cool. As you can see, we have seen Bob and age and create time and income, just like we inserted. Okay, this is how we're using a native table for simple queries. But unlike an explicit table, you cannot drop a explicit table. You cannot drop a native table because it's a native topic and it's mapped directly from Pulsar topics. You do not have the authority to, or we do not want any Flink programs to have access to deleting or adding new topics within the Pulsar clusters. So that's all about the native table. So far we have covered the explicit table and native table. This is just some very basic use cases. And for more advanced use cases, you can go to the Flink example repository and see if there is any cookbooks and examples that suits your foot. Okay, and that concludes our demo today. And next, I'm going to share some tips and resources. The first tip is to choose the right format. This can be tricky because some Pulsar schemas are not supported by Flink formats, and some are not mapped one by one. So protobuf and protobuf native is not supported yet, and we plan to support them in the future. And if you want a complete list of format recommendations, you should go to the a link in the. You should go to the link of the official documentation. Also, the Flink interact with Pulsar topics using byte schema. That means everything, whether it's sending out or receiving from the Pulsar side, it will be byte schema. For example, if a Flink SQL job uses JSON format to produce to Pulsar topic A, then any other consumers, and very likely not Flink, some like applications, they can only use byte schema to consume from the topic A. They cannot use a JSON schema here. The second tip is about packaging and dependencies. We recommend using the Flink Pulsar connector image as a base image. The link is provided at the end of the presentation as well. Within the Flink Pulsar connector images, it has some dependencies like Pulsar all. And if you want to run a table API program where you still need a jar, you must make sure that you will not package any conflicting jars into your applications. For SQL clients, and there are only JSON, Avro, and CSV formats included in the image itself. And if you want to add any other Flink formats, you need to build a new image. Well, lastly, there are some useful resources. The first is more like an announcement because after Pulsar SQL Connector is ready in beta state and you can test it out. We didn't cover a lot about the after Pulsar SQL Connector or what it is, but basically it supports not only insert queries, but also update and delete queries. Here in documentation page, we have a documentation page hosted on the StreamNative, mainly because we haven't merged contribute back the SQL connector to the upstream official Flink repository, but we're on our way to do that. The Docker Hub has all the images you will need to use, and you can check it out. And finally, it's an example repository having all the Flink and the Pulsar cookbooks. It contains DataStream examples and the SQL examples at the same time. Feel free to check them out. Okay, this pretty much sums up my presentation today, and thanks for attending. See you next time.